So in this final movie I want to talk about some extra little bits and pieces and give some tips and tricks with the Heliodon and talk about some stuff that you may not discover straight away. So let's switch to the model file, and the first thing I want to talk about are horizontal and vertical shadow angles. Now for those young'uns out there who may not have covered this topic during their degrees, I've got a little graphic here explaining what horizontal and vertical shadow angles are all about. If this little sphere here represents the sun, if you project a line directly down onto the ground and then to the center of the wall, then this angle around here is the horizontal shadow angle. And if it's if you're standing with your back to the wall looking out, if it's on the left hand side, then it's a negative angle, so 0 to minus 90. And if you're standing with your back to the wall looking out and it's on the right hand side, then it's a positive angle. Okay, so that's the horizontal shadow angle. The vertical shadow angle is the angle between the ground and a plane that is developed by the position of the sun and the bottom of the wall. So you can see this yellow plane here, and this blue angle represents the vertical shadow angle. So what the Heliodon can do is to tell you these angles for any given wall. Whoops, let's go to our model. And it can do this if you make a couple of simple adjustments to some walls in your drawing. Let's go and look at what those are. So here I have 3 walls that I want. I want to have the shadow angles on the east, west and north walls. So I've just really picked any walls. It actually doesn't matter provided they're facing the correct direction. So this wall is my west facing wall, and I have given that the name wall west up here. And this is my east facing wall, and I've given that the name wall east. And this is my north facing wall, and I've given that the name wall north. So that's pretty simple. The only other thing that you've got to do is to make sure these walls are consistent in the way that they've been drawn. Now walls have a left and right orientation. It's not inside and outside, because obviously with an internal wall it doesn't have an inside or an outside. So walls have a left side and a right side, and you can tell which is the left side by looking at the little arrow here. And that arrow, if you stand at that arrow and look along the wall, then this is the left side of the wall. In other words, your left side is the left side of the wall and your right side is the right side of the wall. So with this, the arrow is at the top, so this becomes the left hand side of that wall. And with the north facing wall, again standing with your standing at the arrow looking along the wall, then the left is outside and the right is inside. So we need to just make sure these are consistent, which they are. So left is outside, so just keep that in mind. Let's go back now to our plan, and we'll select one of the Heliodons here, and you'll see here that we have the show shadow angle calculator, and we can choose for the number of walls we want. We've named 3 walls. You can do up to 4. And here, this is important, wall face, left side of wall is external. So you've got to either have all of the walls with the left side external or all with the right side external. And once you've done that, then you're going to see the horizontal and vertical shadow angles for each of those walls. If there's no sun on the wall, then as it is the case with the west wall, given it's 9 AM in the morning, then this will say no sun on the wall. So you can use those shadow angles to design shading devices. Now, if you want to visually assess a shading device, then it's a good idea to position the Heliodon right at the place that the shading device exists. And I'm going to do this as a 2-step process. The Heliodon, the sun of the Heliodon, is actually in the center of the graphic here. So I'm going to click and drag this up here, which is where I need it, and this is appearing This is on a layer that's below some other layers, which is why it just disappeared. And I believe this shading device is 7 meters, so I'm going to put 7 meters in there, and we're good to go. We'll just render this in OpenGL. And it's just rendering, and now we'll click solar animation, and you can see the Heliodon sitting up there. And what we want now is view sun to Heliodon center. And when we do that, and we'll just scrub this backwards and forwards a couple of times until it becomes clear. There we go. So you can see the model is now rotating about this point right here. Now, to make it a little bit easier to assess, it would be better if I zoomed in a bit. So I'm just going to click OK and maintain that view, and zoom in here quite a few times so that I can get a clear view of this, and you can see the Heliodon is right there. So click on solar animation, view sun to Heliodon center, and this is going to move the model, or move that point of the model right into the center of the screen. And now I can scrub through this, and you can see that the model is rotating and keeping the center of rotation about the location of the Heliodon. So I can now look through the pergola here, look at the windows, and decide, look at the time of day, and if I can see the windows, then so can the sun, and the sun is hitting the windows. So as I move through here, at about this point in time, there's no longer any sun on those windows. And of course I can also scrub through the time of the year as well. So you'll see coming through to winter, the sun is much lower in the sky, and so I can, you might say, well, I want this to be, these windows to be shaded from September to April. So we can look at this now and make an assessment, and if you see the windows, then they're not being shaded. Now these pergolas may well not have been designed as shading devices, but so I don't want to imply any criticism here, because these rooms may require solar access or whatever. But the idea of this is to be able to assess these things and then make a judgment, make adjustments, and so on. And of course, with any of these views, if you want to create a viewport, you just click OK, and that will be the view that you that will remain when you click OK. So that hopefully gives you a little bit of assistance in designing and assessing shading devices. So the next thing I wanted to look at is proposed and existing shadows, and we'll go to our sheet layer, and here we have one viewport with our normal kind of shadow rendering on it. And there are various scenarios for this, and you'll have to kind of take what I say and adjust it for your requirements. But here, for example, I could turn off the neighboring buildings and have a difference between these two viewports, and then you'll see what I'm about to do. It can then composite a couple of different viewports together. So for example, in this one we could go to layers and turn off all of the proposed building layers and update that. So we kind of got a couple of scenarios here. It might be that that you want to combine, you want to do something like this, but combine the shadows from different times of the day or whatever. So let's now change the render mode of this viewport to and I'll choose the one that has the OSCAD one with the red shadows, and we'll click update. And what we're going to get here are all of the shadows in red. Okay, so these represent existing shadows, let's say, and this represents proposed shadows. So obviously, if I just put this over the top of the other one, it gets obscured or underneath the other one. So here's the tip, and it's probably a good idea to keep a copy of this down here. What I'm going to do is to select this viewport, go to the Modify menu, Convert, and Convert to Group. And essentially this just creates or converts this to a bitmap image. And although it says Group, if I was to ungroup that, you'll see it's just a bitmap image. And once it's a bitmap image, then I get to control the opacity of it and whether it has any fill. Now I'm going to bring this to the front. It may already be at the front, but let's bring it to front. And you'll see if I put this over here now, that the white parts of this become transparent unless it has a solid background. So you've got to make sure that when you're doing this that there's no solid background, that the fill is set to none, so that makes any white areas transparent. And the next thing I'm going to do is to change the opacity of it and knock that back down to, I don't know, 50% or something like that. And so now what I can do is to pick up this and to let's just align these two, make sure they're aligned. I'll use the Align and Distribute. And so now I have a composite view of the two viewports, and by controlling the opacity I can adjust what might be existing and what might be proposed. So I'll leave that one with you because it does actually provide some quite interesting alternatives. So again, all you need to do is just convert that, is to render it in whatever render mode it is, using whatever shadow color you like, and then you can ungroup it or convert to group and change the opacity. So hopefully you've learned a bit about using shadows in Vectorworks from these 4 movies, and can put it all to good use.